Here's the second example. This is section 3.1 part E. So as we take a look at this, the first thing we need to do is determine what the domain for this function is. Well, if we look at it, we are in no danger of dividing by 0. So that means then my domain is all real numbers, so negative infinity to infinity. Now, the x-intercept is where the numerator equals 0. So x squared equals 0, which means x equals 0 as well. So the x-intercept is 0, 0. So ironically, well, not ironically, but that's also going to be our y-intercept. So that looks good too. Okay, so y-intercept and the x-intercept are both going to be the origin. Now when we look at this denominator, it's never going to equal 0. So that means then that I have no vertical asymptotes. Now, as I take a look then here, we see the degree of the numerator is 2 and the degree of the denominator is 2. So since they're the same, the ratio then between the top and the bottom is going to be then our horizontal asymptote. So my horizontal asymptote is going to be then y equals 1. So again, I'm going to go ahead, draw in then my horizontal asymptote going from side to side. Okay. So then from here, okay, my next step then is to go ahead and to evaluate that first derivative. So we're going to go ahead, take then the first derivative of that function. So we're going to go ahead, we're going to use then the quotient rule. So this will be then the bottom times the derivative of the top minus top times the derivative of the bottom all over then the bottom squared. Okay. So now from here, we're going to go ahead and multiply this out. This will be then 2x cubed plus 16x minus then 2x cubed over then that bottom. So x squared plus 8, the whole thing then to the second power. Combining like terms then, this then gives me 16x over x squared plus 8 squared. Now, as we take a look at this, we're looking for our critical values. So we're looking then to set this then equal to 0. Well, we have no values for which the denominator is going to equal 0, so it's going to come straight from the numerator. So in other words, 16x then equals 0, which means then x equals 0. So we have our critical point. Our critical point ends up being very nicely for us right where our y-intercept is. Now the downside is I can't pick my favorite number, but that's okay. We're going to go ahead, we're going to pick our favorite value less than 0 and our favorite value bigger than 0. We're going to go ahead then, we are going to plug this then into our first derivative. So as we take a look at this then, that's going to be then 16 times negative 1 is a negative 16 over negative 1 squared is a positive 1 plus 8 squared. So this then gives me a negative 16 over 81, so that's going to go ahead and be negative. In the same breath then, we're going to go ahead, looking then at r prime of 1, that's going to be then 16 times 1, which is 16, over then 1 plus 8, which is 9 squared. So that's going to give me then 16 over 81, which is then positive. Alright, so looking at this then, we're going to be decreasing. We're going to be decreasing then from negative infinity to 0. And then we are going to be increasing then from 0 to infinity. So kind of a rough draft, it's going to look then kind of like that. Which means then, since we are not undefined at 0, okay, we are going to have then a local min at x equals 0. So we're looking for a minimum value then at x equals 0. Alright, now we didn't have to take the limits in this one because we did not have any vertical asymptotes. Alright, so we are increasing them as we go for, or excuse me, decreasing then from 0 to infinity. Something's okay. We are decreasing then from negative infinity to 0, and then we are going to increase then from 0 to infinity. Now, mind you, we have this horizontal asymptote here, so we're going to get really, really close. We are going to be decreasing them as we get closer and closer and closer to 0. Alright, and then we're going to bounce back up and approach that horizontal line then again. So the graph will look then something like that. Alright. If you have questions, feel free to email me. I will also upload these notes as well. Thanks!